So, Biochemistry Module 2, Introduction to Biochem, pH, and buffers. So, we have number 1, water. What is water? It is considered weak electrolyte, both amphoteric and amphiprotic in nature. So, when we say amphoteric, it can react as an acid or base. However, kung amphiprotic siya, a substance that can be both accept and donate proton, hydrogen. So we can tell the chemical reaction is in the equilibrium if we can see the sign of this one. It stands for an arrow like this and an arrow like that. Pero the shortcut is that one. Now, it means the reaction is reversible. So, ionization constant of water or Kw yang sign or ang yang sign niya or ionization constant, no? Where the F is the formality and M is the molarity. So, when you want to get the formality or when you want to get the molarity, F is equivalent to gram divided by formula weight. And if you want to get the molarity of the substance or the substance is gram divided by molecular weight. So, dintanin mo ka ang aton nga molecular kag ang formula weight. Mabalik naman kita sa aton nga periodic table. Where, nabalaan ta na ni, na-discuss na ni sa inyo sang inyo nga high school. No? Periodic table ta, diin ta makita si amoni, paano kaon ang periodic, ang molecular weight, paano kaon ang formula weight. Okay. We have pH expression. It was introduced by Danish biochemist named Søren Peter Lauritz Sørensen or aton nga ginatawag sa nga Sørensen only. So the pH scale is telling you kung acidic or basic ang aton nga substance. So ang aton nga neutral, let's say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So the more acidic ang substance, the lower the number. However, the more acidic the substance, the lower the number. The more basic ang substance, the more higher the number. Okay. Ko ang aton nga neutral is 7, no? That is the amo na siya. Hindi ako mamangkot nga mangkuton nyo to si Søren Peter Lauritz Sørensen nga ginbutang niya nga 7 is the neutral, no? I really don't know how he made the number 7, but it is what it is. So the more higher the number, the more basic ang substance, the lower the number, the more acidic ang substance. So kung number 1, for example, may ara kita na instrument, no? Masulat, madraw ta di. Let's say, may ara na siya instrument class sa aton nga laboratory. na. Wow. Okay. Sige. Tapos, sa sulod sina, no? Sa sulod sina, may bulb na da siya, nga gamay. That is very sensitive. No? Ang bulb na. Bulb. Ay, bear with me, bulb. Okay. Ang bulb na, that is very sensitive. And there is an indicator here. Indicator kung ano nga number. Matel na siya kung ano na siya nga number. You dip it in a may ara kita petri dish. Let's say petri dish or beaker. Small beaker. We have a small beaker here. No. A beaker where there is a substance or a known substance be. And then you put this instrument, no, padalom, so that the bulb will totally submerge to the substance. And then ang ma-indicate niya siya kung ano nga number, and it will tell you ano ang iya pH. Usually, ginagamit niya siya in aquariums also. Nagamit man niya siya sa laboratory if you're having an experiment or you have a research. So, mana. Kung again, the more acidic the substance, the lower the number. The more basic the substance, the more higher the number. So, I have this pH scale from inside out. So, acidic si anger. Si sadness, medyo neutral until sa fear ni siya ata. Nalipat ako sa ano. Ashamed. Nalipat ako. Anyways. So, amo na siya. Kung acidic, red. No, red. Ang usually, ano ni siya, ang color is ara na siya sa aton litmus paper. No? Kung red gani acidic, kung blue gani basic. Okay. So we have different kinds of formulas in how to get the pH, the pKa, the pOH. So magwa niya siya sa exams niyo. So you have to know how to calculate. So, ang aton nga first nga question is ang ara sa formulas sa aton nga sample problems. Number 1, what is the pH of the solution if the concentration is, molarity of the concentration is 5.5 times 10 negative 4. So, you have to get your calculator. Calculator lang please para hapos sa inyo, hindi nyo ni compute. Ito na ka mapagpabudlayan. Hindi nyo napagpabudlayan lawas nyo how mag-manual. Kaya hindi nyo giniya ma-manual. Okay, number 1, the H3O positive. Molarity is 5.5 times 10 negative 4. Paano ni siya expand? Balanta na ni, di ba? 5.5. So, move to the left or right. Since negative 4 siya, move to the left. Hindi siya sa right. Kay negative, no? 1, 2, 3, 4. So, we have, amo na siya kung i-expand siya, ha? So, amo na. Anyways, I know you tackled this already in your high school. So, I'm just refreshing everything. So, calculator, maski check nyo pa sa 5.5 times 10 negative 4. Expound nyo siya muna. Anyways, ay, hindi siya ma-erase. Okay. So, makadto kita sa number 1. Amo ni siya ang aton nga. So, molar. Tanawon nyo sa formulas kung ano ang ara na nga daan. What is given and what is asked. So, ginapamangkot is pH. No? So, tanawon nyo dire, anong mga pH di nga ara nga pwede makwa? Anong pH nga formula? So, this could be 1. This could be 2. And this could be 3. Pero, you have to eliminate man also, paano nyo siya kwaon? Anong given? No? So, wala kita ginhataran POH. So, this is cancel. This is also cancel. Kaya wala kita log. So, the best option, the best formula that you could get is this one, number 1. So, paano? So, pH is equivalent to negative log. Butang nyo na lang 5.5 times 10, negative 4. Okay. So, your answer would be negative log. Butangan nyo lang minus log 5.5 times 10, negative 4. Close parenthesis. The answer would be pH is 3.26. So, medyo acidic or basic? We call it acidic. So, number 2. So, number 2, we have, we have the pOH of the solution. So, ang given is pOH. The solution is 5.7, slightly acidic. And then, calculate the pH of the solution. So, the pamangkot is pH. Okay. So, sa formula nga pamangkoton nyo naman, ask yourself, ano ang formula for the pH? So, the 3 checks that I gave you here in the screen is 3 lang. So, mangkoton nyo naman sa self nyo kung ano ang given. So, the pOH, right? So, hindi na niya pwede. No? Are, wala kay log. This one, may pOH siya. So, amo nang gamiton ta. No? Paano galing, ma'am? Paano siya nag-amoni? I already know, nga gin-discuss na sa inyo ang transposition, no, sang formula. Paano ka mo mag-manipulate sang formula? So, formula natin is 14. For those who do not know, I will give a quick review. Okay, plus pOH. So, 14 is equivalent to pH. Sorry. Wait. So, maning formula. This one. Galing, hindi ka mo kabaloma. May some of you do not know how to transposition. No? 'Di ba ang rule ta sang una, since elementary to high school, i-transfer once the transfer ta ang isa ka item nga may equivalent or may equal sign, ma-negative siya. So, dapat tani siya i-isolate para makwata siya, para maging ammonia siya pOH, matransfer na siya mo. Ang pH, matransfer na diri. So, imbis nga positive si pH, ma-negative siya. So, once na-transfer na siya, amuning matabo. POH is equivalent to ay hala, sala. Sorry. Ang pH gali ang matransfer. So, transfer si POH, makadto na di siya. Imbis nga mag-positive, ma-negative. So, pH is equivalent to 14 minus 5.7. Again, liwaton ko. I will delete this one. Okay. We will use the formula 14 is equivalent to pH plus POH. So, kailangan ta ang pH. So, POH must transfer to the 14. Are, 14. Matransfer siya. So, 14 minus POH is equivalent to pH. Diba? Amo nang matabo. Ang tsakto nga pag-write is pH is equivalent to 14 minus POH. So, butang ta na. Right? 14 minus 5.7 pH. pH is equivalent to what? 8.3. Okay. Number 3, sorry. Number 3, if the POH is 4.3, what is the OH concentration? So, the question asked is OH na naman, question mark, and the POH is 4.3. So, mabalik naman kita sa formula natin, pero sa inyong nga exam, wala na niyang formulas, you have to memorize. So, please memorize this one. So, number 3, ginapamangkot ang OH concentration. Diin diri ang OH concentration na formula. This one, right? So, anti-log negative POH siya. So, OH anti-log negative POH. Mutang nyo lang na sa inyong calculator. Anti-log naton. Wait lang. Shift log. And then 4.3. Wait. Okay. So, ang aton niya, hindi siya budlay siya, lain ang anti-log, lain ang log negative. Paano siya naman? Kadto ka mo sa shift, tapos kadto ka mo log, Tapos, butang nyo ang 4.3, no? 4.3 or negative. Kay negative log siya di. And that would get 5.01 times 10 negative 5. Or other niya nga paano ka muna siyang magwa sa inyo nga calculator. May sa settings siya. Settings nyo, either amuning magwa this one or this one. Kay gin-expound nyo lang. Okay? Kung paano siya ibutang sa calculator, this one, shift, and then log negative 4.3. That is your answer. If you have questions, I could answer that next face-to-face. Number 4. So, number 4, we have what is the pOH of the solution if the H3O positive concentration is 5.2 times 10 negative 3. So, ang pamangkot is pOH. And given ang molarity is 5.2 times 10 negative 3. So, mabalik naman kita sa formula. So, are. No? Amo na gamiton ta. Ay! Sorry. No. Not that one. Gamiton ta is this one. Anay? Number 1. No. Yes. Wait lang. Ammonia ni gamiton ta to get the pH, and then we will get this one. Number 2. Amo nang formula ta. Medyo budlay si number 4, right? Kay wala kita direct nga formula just to get the pOH kung wala kita sang pH first. Kay ang given only is this one. I hope you understand. Number 4, pOH is the question. Anong pOH? So, to get the pOH first is we have to get the pH. And then, after when we get the pH, we will transition or transpose the formula to this one para makuha ta. So, number 1, yung formula, formula number 1 is pH is equivalent to negative log H3O positive. So, anong answer? Negative log minus log 5.2 times 10 negative 3. So, answer is 2.283996656. Okay lang na. Pwede siya Okay. First formula. Second formula is 14 is equivalent to pH plus pOH. So, ang pamangkot natin sa number 4 is how to get the pOH. So, i-transfer ni si pH. Since positive siya diri sa side, ma-negative siya, 14 minus pH is equivalent to pOH. Or, tsakto nga pag-write, sang formula is 14 minus pH. So, transposition, ang aray natin yung formula, 14 minus 2.28. Answer would be, POH is 11.72. So, that is your formula. Or that is your answer. Okay, number 5. I hope everyone will get this. Medyo budlay siya. Pero if you think or if you already know how to manipulate the formulas or you already memorize the formulas, you would get that. Number 5. If the Ka of an acid is 1.7 times 10 negative 5. Calculate the pKa and pKb values of the acid. So, pKa is the question and the pKb. So, we have to use the pKa negative log Ka and the formula also nga 14 pKa plus pKb. Manang formula natin. This one and this one. So, 1 and 2. So, paano? pKa is equivalent to negative log 1.7 times 10 negative 5. Answer, that would be 4.77. Okay, that is the pKa. So, 14, ang aton naman na pamangkot is pKa na, tapos na ni pKb naman. Since si pKb, ay siya sa formula, ibutang ta naman si pKa diri. Since positive si pKa, negative naman si pKa, I will just 14 minus 4.77. pKb, answer, 9.23. pKa, pKb. Okay. Questions 4. Save it for the next face-to-face. So, buffer is a mixture of weak electrolyte with its salt. No? Buffer. Buffer is a mixture, MX ko na lang ha, a weak electrolyte with its salt. So, function, resist drastic great marked change in pH of a system upon the addition of either a strong acid or a strong base. So, yeah. Function, resist drastic, resist na siya, resistance na siya ha. Drastic or great marked change in the pH. Strong acid is sometimes SA or strong base. Strong base. Ang SB is strong base sometimes. So, there are two types, no? Acid buffer, and we have two types of buffer. Acid and base. So, we have a mixture of weak acid, salt. Mixture of weak acid plus salt of weak acid. Sa base naman niya, mixture of weak base plus salt of weak base. So, examples of that, we have, so neutralization is example, base plus acid, salt and water. We have NaOH plus HCl is our hydrochloric acid. And then the NaCl is sodium chloride or the salt water. No? Seawater, pwede. HOH, water. H2O. So, we have, wait lang. So, we have buffer works. No, buffer works by neutralizing the added acid or base to maintain the moderate pH, making them a weaker acid or base. So, ang aton yung mga theories, we have different theories for that. Medyo madugay-dugay ini. So, we have theories for acid and base. We have Arrhenius. Si Arrhenius, may ara man kita Bronsted. Ay, hindi. May ara kita Lewis. May ara man kita Bronsted-Lowry. Ang other name for Arrhenius is ionic. Sulit. Ionic theory. We have si Lewis. Siya lang. Wala na naging discuss. Si Bronsted-Lowry theory, or other name of it is conjugate acid-base. Pair theory. So, butang ko niyo siya as a table for you. So, we have Bronsted here. We have acid here. Acid, very base. Okay. So, hambal ni Arrhenius or ionic theory, hambal niya, gayield ang acid sang hydrogen, water, solution. However, hambal naman ni Arrhenius, si base naman, ga-yield OH in water solution. Hambal naman niya ni Lewis, when it comes to acid, electron pair acceptor naman sila ya. Electron pair acceptor. Hambal naman ni Lewis, when it comes to base, electron pair donor naman siya. Hambal naman ni Bronsted-Lowry. Kung si Bronsted-Lowry ni duwa ni siya ka person, two people, nga nag-ubas ang theory, that is why amo na ilang ang ngalan. Hambal naman niya ni Bronsted-Lowry, hambal niya, proton donor ang acid. Proton donor. Kung basic naman, proton acceptor. So, are, non-negotiable nga dapat tunan nyo. Kung Arrhenius, acid, ga-yield hydrogen ng acid. Kung base, hydroxide. Amo lang ng tandaan. Tapos, amo na lang nitandaan nyo, kaso depende sa inyo kung anong tandaan nyo, acid or base. Kay, interchange lang man ni sila. No? Kung mambal kita nga Lewis, pair electron, kung sa Bronsted, proton donor siya. Amo na lang natandaan nyo para hindi na yawan. Pero depende man sa inyo. Lain-lain kita nga learner. We have different kinds of learner. Kung either gusto nyo photographic git, gusto nyo ginawakal, or gusto nyo auditory ka mo, or kung gusto nyo may araman ng mga learners nga ginasulat gid. In my case, I am gasulat gid. Okay, sa Lewis palatandaan natin is this one. Si Lewis, we underline the word L at the E to memorize or to understand that Lewis tells about the electron pair. Kung Bronsted-Lowry naman niya, ang ato naman nga palatandaan is we have this kind of thing in pharma that we mention things over and over again para magtapik sa utok. So it may sound cringy, but Bronsted, proton. Again, I will repeat. Bronsted, proton. Para mabalaan ta nga si Bronsted-Lowry is talking about the protons in acid base. Again, there are theories about acid and base. We have 3. Number 1 is Arrhenius, number 2 is Lowry, and number 3 is Lewis, and then number 3 is Bronsted-Lowry. So, si Arrhenius, hambal niya, acid yields hydrogen in water solution. Hambal naman ni Arrhenius, base yield hydroxide in water solution. So it's a straight fact. Tandaan na lang. Memorize na lang na. The problem here is si Lewis kag si Bronsted medyo confusing. So para matandaan ta kung ano ginatalk ni Lewis is we underline the word E to signify that Lewis is talking all about the electron pair. However, Bronsted-Lowry is talking about the protons in the acid base. So we have palatandaan Bronsted, proton. And kung ginatandaan ta na lang ang acid, mabalaan taman nga kung electron pair acceptor ang acid, proton donor naman si acid sa Bronsted. So, ano lang siya, inversely proportional, no? Magambal kita. Inversely proportional lang ang aton nga Lewis kag Bronsted in acid and in base. Okay. I hope I make myself very clear. So we have conjugated base. We have conjugated base and conjugated acid. So an ion produced from the dissociation of acid, removal of hydrogen, and conjugate acid is proton hydrogen donor formed when it combined with hydrogen. We have conjugate acids and conjugate bases. So we have hydrogen chloride, ano niya siya? Okay. So, I will discuss this in your face-to-face na lang. Ha? Conjugate acid and conjugate bases. So, we have NH3 or ammonium plus H2O and H4 plus OH. This is ammonium and ammonia. So this is water, this is hydroxide. So, paano ito mabalaan? Kung conjugate acid or conjugate base by doing this. So, kung NH3, balaan ito nga si ammonia, mabalik naman kita sa aton nga periodic table. So, usually si ammonia is base. So, i-connect lang na siya, pakadto diri. This is conjugate acid. And this, no, pwede ka niya siya mag-act as a base or an acid. Pwede niya siya. So, hindi ta ma-look kita sa another niya nga partner, which is this one. So, mostly, ang OH or ang hydroxide, no, is basic. Sorry. Conjugate base. So, we would assume nga acidic niya siya. So, ammonia siya, no? And then, we have the equation of pH is equivalent to pKa plus log conjugate base acid. This is what you call Henderson-Hasselbalch equation. So please memorize. This will come out in your exams. Yeah. Hindi na yung maiwasan. Magwa gina. And we have another sample problems where weak acid and base buffer cells into tissue against pH changes. And in cells and tissues, phosphate and bicarbonate buffer systems maintain intracellular and extracellular fluid in their optimum physiological pH, which is actually close to pH 7. So, pH 7 is our neutral. So, enzymes generally work optimally at this pH, number 7. The intracellular and extracellular fluid of multicellular organisms have a characteristic and nearly constant pH. The organism's first line of defense against changes in internal pH is provided by buffer systems. The cytoplasm of most cells contain high concentration of proteins, and these proteins contain many amino acid with functional groups and are weak acid or weak bases. So, I will tell you later ano ang intracellular kag ang extracellular naton. Nga akilanlan ta maging pH 7 sa aton nga mga usual nga mga sa aton cells, no? Kay may ara kita swelling, may ara man kita shrinking sa aton cells. Kung hindi mayo ang aton nga hindi mayo aton nga pH number. So, I will tell you na lang sa face to face ha. Number 1 para matapos na lang ni. Number 1, we have what is the pH of mixture? Okay, I will 5. No. I will quiz this soon. Ang sample problems. Okay? For now, that's it lang, Anay. Thank you.